so for infinite limits, your definition of a vertical asymptote, we've talked about vertical asymptotes a lot, we've seen them on graphs, but your definition is that if the limit as x approaches c from the right of f of x equals positive or negative infinity, or the limit as x approaches c from the left of f of x equals positive or negative infinity, then x equals c is a vertical asymptote. So notice that you have an or right here. So you can have a vertical asymptote that is one-sided. It only has to approach infinity or negative infinity from the left or right. It doesn't have to be both here. So the main thing that we have seen that causes a vertical asymptote is the denominator of a simplified function is 0. So that means you've already factored and canceled, and you still have something in the bottom that's giving you a vertical asymptote. So we're going to just go over these first few quickly because this is sort of a review that we've been over. So vertical asymptotes are going to be whenever we have a denominator equal to 0 and nothing in the top cancels. So in this case, you could include the 3 if you want, but it's not going to affect anything. It'd be where that x plus 2 equals 0. So you would have a vertical asymptote at x equals negative 2. Okay. The top isn't going to cancel with anything. Number 2, you've got x squared plus 4 over x squared minus 4. So the top will not factor, so it will not cancel with anything. The bottom, you could factor it if you want, or you can just solve it like this. X squared minus 4 equals 0, so you could move the 4 over to the other side. X squared equals 4. But be careful whenever you square root both sides. If you do it this way, you're going to get x equals plus or minus 2. And since nothing cancels here, also you have vertical asymptotes at x equals positive and negative 2. For number 3, this is a little bit like the problem that Hannah asked about from last night. You've got cotangent of pi times x. So any trig function besides a sine or cosine is going to have discontinuities. I always think of it like this. This is cotangent, so it is going to be cosine of pi x over sine of pi x. And then if we think of our unit circle and think of our values here, we've got 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And sine is going to be my y-coordinate. So that y-coordinate is going to equal 0 right here and right here. And so that is at, we've got 0, pi, we can call it 2 pi if we wanted, 3 pi, 4 pi, 5 pi, and so on. So anything that's going to give us 0 pi, 2 pi, 3 pi, 4 pi, and so on is going to give us a 0 in the denominator. But we've got that pi there with the x, so rather than just saying, like we want to say that it's pi, 2 pi, 3 pi, dot, dot. But pi times x is going to equal all of those things. So if pi times x equals 0, well, if pi times x equals 0, x still equals 0. But if pi times x equals pi, then we divide both sides by pi, and x would equal 1. Or if pi times x equals 2 pi, then divide both sides by pi, equals 2. Or you can just kind of think of it, if what you're going to get in here is 0, pi, 2 pi, 3 pi, 4 pi, and the pi is already there, then that tells us that the x values are just going to be 0, 1, 2, 3, and so on. So you would have, basically you're going to have a vertical asymptote at every integer value that you have for that problem. Questions? All right. Okay, so if we have a problem like number 4 here, and we need to find the vertical asymptotes for this graph, then we would factor, and we would have x plus 4 and x minus 2 in the numerator, and we would have x plus 2, x minus 2 in the denominator. And so here is a case where these will cancel. So at x equals 2, we have a hole in the graph, so we would only have a vertical asymptote at x equals negative 2. Okay, questions? All right, so infinite limits are going to occur at vertical asymptotes. It's the only way you're going to have a limit where your answer is infinity. So we have an example right here where we've got the limit as x approaches 1 from the left of x squared minus 3x over x minus 1. So we might be tempted here to factor x times x minus 3 over x minus 1, but you see that if we do that, nothing cancels. So we are supposed to always, for every problem, we're supposed to use direct substitution first. We probably don't actually do that. I know that I do not actually do that most of the time when I'm doing a problem. But if you can't get something to factor back up, you probably should have tried direct substitution. So if I try direct substitution here, I get 1 squared minus 3 times 1 over 1 minus 1. And so when I do that, I get 1 minus 3 over 0, which is going to give me negative 2 over 0. I don't know why it's putting all those funny lines there. So this automatically tells me that the limit does not exist. And in some cases, it would be plenty enough to just say the limit does not exist. However, especially in the section 114 called infinite limits, I'm probably going to care about whether or not it's positive infinity or negative infinity, or it could still be does not exist, depending on what you're looking at. If it's one-sided, it's usually going to be positive or negative infinity. If it's from both sides, it might not be. Excuse me. So, in this case, there's some different ways that we can figure this out. For some of these, I'm going to give these to you, and they're going to be calculator inactive. So, if this problem is calculator inactive, you basically have to resort to plugging in some numbers to figure out what's going to happen here. So we're going to do it calculator inactive, then I'll also look at the calculator quickly so we can see what's happening. Calculator makes it a lot easier, but they do put some of these on the calculator inactive section sometimes, so we have to be able to figure it out both ways. So it might be, I'm going to go ahead and factor like I had before, just because I think it's going to make it a little easier to do the problem here. So So if I make myself a table, I need to approach 1 from the left. So I need values below 1. So I'm going to start at, let's say, negative 2. And so if I did negative 2 times negative 2 minus 3 over negative 2 minus 1, I'm going to get negative 2, I don't know why it's doing this, times negative 5 over negative 3. I will get positive 10 over negative 3, so I get negative 10 thirds whenever I plug in negative 2. And then I could plug in negative 1. And so negative 1 times negative 1 minus 3 over negative 1 minus 1 is going to give me positive 4 over negative 2, which is going to give me negative 2. I could plug in 0. So if I do that, I'm just going to get 0 over 1, which is 0. And I can't plug in 1, because if I plug in 1, that's where I get the negative 2 over 0. Just to really feel assured of what I should do here, I'm going to do 1/2. So if I do 1/2 times 1/2 minus 3 over 1/2 minus 1, I would get 1/2 times negative 5 over 2. Sorry about all the black marks that keep showing up. Over negative 1/2. And so I would get negative 5/4 over negative 1/2. And dividing fractions is easy as pie. Flip the second and multiply. And so I would get negative 10 over negative 4, which would give me 5/2. So as I look at what's happening to the numbers, are these y values, are they increasing or decreasing? They are increasing. And I could use something like 1/10 or 1/100th or 1,000th that would show that this is really going to approach positive infinity here. But if I just can get the general trend, that's good enough for this. So we could say that the limit does not exist. That is true. But look at this. What is it doing? It's just going crazy. I'm not touching anything. So we could say positive infinity if my pen would write without doing crazy stuff. So I might have to close this out and try again. But positive infinity would be your most specific answer here. If you had a multiple choice problem, it would not have positive infinity, negative infinity, and does not exist all three as answers. It would just be the probably positive or negative, and then they probably have some numbers or something there. So let me try to close this out, and let's just graph that. Let's see, what was it? X squared. Was it plus 3 or minus 3? Minus 3x over x minus 1. And so if you look at the graph here, we were looking at, for that problem, we were looking at as x approaches 1 from the left. So if you want on Desmos, you can put in a x equals 1. You can see, if I give you a calculator, it's much easier to tell because you just say, oh, I'm going to graph it. Right, here's 1. From the left, the graph goes up, 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 up towards positive infinity. So it's much easier if you have a calculator. However, I'm afraid that you're going to see some of these without a calculator, so we're going to do a few of them without. All right, questions? All right, let's try this next one. See. Okay, so properties of infinite limits. If we have a limit of f of x and we know that limit is infinity, so we have one function, we know that limit is infinity. And we've got another one here, its limit is L. If we have the limit as x approaches c of f of x plus g of x, that would give us, technically it would give us infinity plus L, but infinity plus something else is still infinity. So like whenever Buzz Lightyear says infinity and beyond, it's really still just infinity because you can't go beyond infinity. So infinity plus something is still going to be infinity. If we take infinity and we multiply it by another function, we will kind of still get infinity. If we have infinity and we multiply it by a positive number, then we will still get infinity. But if we have infinity and we multiply it by a negative number, we will get negative infinity. So 2 times infinity is still infinity, but negative 2 times infinity is negative infinity because it's going to change that sign. If we have a quotient, g of x over f of x, so if we get, if what we have here, so like if we plug in, the limit of g of x would be L, and the limit of f of x would be infinity. So we have some number, it might be 5, it might be 10, it might be 1,000,000 over infinity. So that value is so close to 0 that we're going to call it 0 whenever we do the limit process. Because if you think of having a number like 5, if we have 5 over 10, that's 1/2. But if we have 5 over 100, now we're only down to 0.5. And if we have 5 over 10,000, essentially that's basically 0 now, right? And then if we have 5 over a gazillion, and we just put a bunch of zeros, which is what's happening as we approach infinity, we basically have 0. So we would say that anytime you have a number divided by infinity, that's going to be 0. And these properties here also apply whenever you are dealing with negative infinity. So rather than restate them all for negative infinity, just note that they also apply in these cases. So if we have a problem like number 6, we've got the limit as x approaches 0 of 1 plus 1 over x squared. So whenever we do this, we can take the limit, properties of limits tell us we can take these limits separately. So we would have the limit as x approaches 0 of 1, which would just be 1. And then we would have the limit as x approaches 0 of 1 over x squared. And so if we're having to do this without a calculator, if we're thinking about the values of x squared, or values of 1 over x squared, if we plug in, if we approach 0 from the right, let's approach from the right first, those are positive numbers. If we had 3, that would give me 1 over 3 squared, which would be 9. And then if I have 2, I would have 1 over 2 squared, which is 4. 1 would just be 1 over 1, so I would get 1. If I had 1/2, I'll do this one over here to the side, I'd have 1 over 1/2 squared. And so I'd have 1 over 1/4. And dividing fractions is easy as pie. We're going to flip the second and multiply. And so here I'd get 4 over 1, which is 4. And so as I get bigger fractions, I'm still going to flip and multiply those numbers 1/9, 1/4, 1/4. They're increasing as I get closer to 0. Will it make any difference if I have -3? No, because we're squaring that x squared. So we'll have 1/9, and we'll have 1/4, and for -1 we'll have 1, positive 1, and then we'll have for -1/2 we would also have 4. So from the right hand side, as we get closer and closer and closer to 0, our values increase more and more and more. So we approach infinity. Same thing happens from the left. So this limit right here, as x approaches 0 of 1/x squared, it's going to equal infinity. So we have 1 plus infinity. But what is 1 plus infinity? Just infinity. Okay. Questions? Okay, so for example 7, whenever we have the limit as x approaches -2 from the left of x squared plus 1 over 1 over x plus 2. So whenever we look at our properties of limits, we could take the limit of the top and the limit of the bottom, except for that, let's see, hold on. Yes. So in the top, we'll just get 5. When we plug in our -2, -2 squared will give us 4, plus 1, that will give us 5. In the bottom, we're going to get 1 over x plus 2, which is going to be -2 plus 2, which is 0. So that gives us 1 over 1 over -2 plus 2, which is going to give us 5 over 1 over 0. So here we know we've got something where the limit does not exist. So whenever we look at this, if we've got to do this without a calculator, we can actually just look at that bottom part, because our top number we could plug in. We got that fairly well. So we've got 1 over x plus 2. So if we do 1 over x plus 2, then we're going to have, if we have, so we're approaching from the left, so let's use like -1. That will give us 1 whenever we plug that in. If we're just looking at the bottom portion, if we have 0, we've got 1 over 2. If we've got 1, yes. Yes, you're right. Those negatives have gotten messed up. Let's fix that. And so let's try, how about like -5? Does that sound better? So that would give us 1 over -3. So we get -1/3. -4 would give me -1/2. -3 would give me -1. Let's see, 2.5. That's going to give me 1 over -0.5, or 1 over -1/2, which dividing fractions is easy as pie. Flip the second and multiply. So we're going to get -2 here. So what appears to be happening here if we take that limit? we're decreasing, right? And we assume that that pattern would continue. So that bottom part is going to be negative infinity. So if we have 5 over negative infinity, then that would just give us 0 for that. If we look at that one on the graph, let's see, we have x squared plus 1 over x. Is it plus 2 or minus 2? Plus 2. Here, and we're looking at parentheses here. Negative 2. Type this thing in right. X squared plus 1 over x plus 2. Well, I guess that's right. That's right, because we got 0, right? With our answer. So that's correct. I'm looking for an asymptote, but there's not an asymptote at this point. So you would just have 0 as your answer there. Approaches 0. Okay. This is basically what you're going to do. I will admit to you, this is not my favorite stuff to do, especially doing this by hand and plugging those numbers in. So on your homework, I'm going to have you, and I think it's there for you. I think some of those right there, let me just turn and look at it. Page 105. 1 through 4 have graphs, so you can use the graph for those. 13 through 25, just ask for the vertical asymptotes for those. So that's like those first problems that we did. 37 through 47, those are going to be your one-sided limits, and I do want you to try to do those without a calculator. So I do want you to do like I was doing here, where you're plugging numbers in to try to see by hand. But on 49 through 49, 51, 53, and 57 through 60, I want you to use a calculator for those. So you can look at the graphs. Sometimes on the graphs you might have a hard time getting a good picture, so if the graph is not working, you could also use a table on the calculator. So I want you to use a little bit of both as you look at those. Okay. Any questions?